Hello, my name is Stuart Wellington. I'm a Senior Project Engineer for Fischer UK, and today we're going to go through the aspects of the Building Safety Act 2022 that will affect the design, specification, procurement and installation of post-installed anchors as well as other construction products. As you may already know, the Building Safety Act is the biggest change in legislation around construction projects to be introduced in recent history. The reason why we have it is a direct response to the Grenfell disaster back in 2017. When they were looking into what had gone wrong with the building, there were many failings that could have been avoided. Following the disaster, the Hacker Review brought in professionals from other safety critical industries such as aerospace and nuclear, who felt that the current regulations that were in place back in 2017 were not sufficient for the modern day. So we now have the Building Safety Act, and it's important to know that it will apply to all new buildings under construction following the introduction of the secondary legislation in October 2023. However, there will be a stricter regime for higher risk buildings. A higher risk building is one that is either 8 stories or 17 meters or higher, and will include hospitals and care homes in that definition. Today, we're going to concentrate on 3 key components of the Building Safety Act: duty holder competency, the golden thread, and project gateways. The duty holder competency requirements will apply to all buildings, whereas the other 2, the golden thread and project gateways, will only apply to higher risk buildings. Overseeing the introduction of the Building Safety Act and the required legislation is the Building Safety Regulator. Now, this will be a division of the Health and Safety Executive and will be responsible for the implementation and enforcement of all the new legislation under the Building Safety Act. The first of the recommendations we will look at is the golden thread. So, following the Grenfell disaster, it was very difficult for the investigators to work out exactly what had gone wrong with the building that led to the tragedy. The reason for this is that all the safety critical information regarding the building was held on different platforms by different companies, with no one body overseeing all the information. So the purpose of the golden thread is to avoid this happening again. So the principal contractor will be responsible for collating all of the safety critical information regarding the design, installation, and certification of all safety critical applications for a construction project. Next, we'll look at the introduction of project gateways. These project gateways are intended to be checkpoints in a project's lifecycle, and any project that started after October 2023 will be subject to the new gateway procedure. Currently in construction, we utilize a project lifecycle of multiple stages. However, it is possible for differing stages to be occurring at the same time. For example, there could be stage 4 design of the building services still being undertaken, with that design not being fully finalized, while at the same time, groundwork, such as the foundations and piling work, are occurring on site. The big change under the new Building Safety Act is that all detailed design of safety critical applications will have to be completed and approved by the Building Safety Regulator at Gateway 2 before a spade can go in the grounds. This means that there will be greater engagement with secondary contractors and secondary designers at stage 3 and stage 4 of a construction project. Moving on to duty holder competency. So this is another big introduction under the Building Safety Act, that all duty holders on a project will have clearly defined competency requirements set out for them. Under the Safety Act, there are 3 key duty holders, and that is the client, the principal contractor, and the principal designer. All required competency for various parties will be set out in the relevant framework documentation. The first one of these documents is BSI Flexi 8670, which sets out the core competencies for all working on a construction project. This has been followed up by the framework documentation for principal designers, and they have 3 key responsibilities when it comes to specification of construction products. First one being the management of all design work for a project. Secondly, they will have to ensure design work compliance across the entire project, so they need to ensure that everybody is designing applications to the relevant design methods. And thirdly, they will be responsible for assisting provision of information to others to ensure that design work compliance. So this is a big change within the industry. Next, we have the framework documentation for principal contractors. Now, the principal contractor will be responsible for the management and supervision of all building work by adopting best practices. So the best way of achieving this is by following the relevant British standards for various applications on a construction project. Next, they will be responsible for the management of competencies for installers for all safety critical applications. So this means that contractors will need to develop methods of measuring the competency of the installers working on a construction site. And thirdly, they will be in charge of the management of the golden thread. Regarding the competencies for construction products, this information is held within BSI Flexi 8670, specifically in section 6.5 and table 5. Now, there's a lot of information in there, but this can be summarized as such. In order to ensure that all parties adhere to their required competencies under the New Building Safety Act, all construction products will need to be selected following the defined process. They will then need to be designed following the relevant design method for the application. And finally, they will need to be installed following the manufacturer's instructions. In doing so, everyone would adhere to the required competencies under the New Building Safety Act. And the best way to do that for post-installed anchors is by following British Standard 8539. Now, this will be the best resource you have available to ensure that you can adhere to your competency requirements. Now, to quickly focus on where we are as an industry in regards to the Building Safety Act. As mentioned already, the secondary legislation came into effect in October 2023. And in February of this year, the main steering group behind the development of the legislation of the Safety Act published their latest report. And in it warned that the industry was not ready for full implementation of the Safety Act. There's still a lot of things that we need to understand. And as Fisher, we're here as a resource for you to use to understand what you need to know around specification of construction products. To summarize the Building Safety Act, you need to be aware of all the duty holders covered by the Safety Act and the required competencies of each of those duty holders. You need to know what information you need to submit regarding specification and installation of construction products into the golden thread. And you need to know what you need to achieve by each of the project gateways, specifically around Gateway 2. I'd like to focus on the importance of post-installed anchors for a moment. We're under no illusion that post-installed anchors are one of the last things to be specified for an application on a project, and they are a low-cost item relative to the rest of the application. However, they have this annoying habit of being the items that keep the application in place and always need to have due diligence paid attention to them. To highlight this, we'll go through the Big Dig case study. The Big Dig was a major infrastructure project in Boston, America, and it was the replacement of the Central Expressway that you can see snaking its way through the city there with an underground expressway system. It was the largest infrastructure project in America at the time, originally costed at $1.5 billion, but that cost rose to $4.5 billion over the course of the project. It opened in early 2004, and unfortunately in 2006, there was an anchor failure that led to the collapse of these concrete precast slabs, and underneath, a car was crushed, killing the driver and severely injuring the passenger. Now, when the NTSB, the National Transport Safety Board of America, investigated what had gone wrong, they quickly identified that the anchors utilized for the suspended ceiling had failed. The reason for this was numerous and detailed in the report that was published a year later. Now, the reasons for the failure included incorrect installation, the change of specification without approval, and then even when issues were noted on site with the displacement of the anchors, there wasn't the due diligence given to investigate the cause of the problem, and therefore it was believed the problem had been fixed until the tragic accident. So in the executive summary of the report, it simply stated that insufficient understanding of anchor systems led to the death of the driver of that car. So the importance of the British standard for post-installed anchors is to avoid tragedies such as the Big Dig and others that have occurred even in this country, even up to the modern day. So the use of such a standard can avoid these issues by ensuring correct specification and installation of anchors, clear definition of the responsibilities of duty holders. The standard will also provide guidance to the duty holders on how to fulfill their responsibilities. The key duty holders under the British standard are the specifier, the contractor, and the installer, with the contractor having overall responsibility for the installer. Key points that all duty holders should be aware of is that for any safety critical application, an anchor with a European Technical Assessment approval must be used. If there is any change to the specification, procurement, or installation of a post-installed anchor, then the original specifier or an engineer with access to the original design data must be notified and approve of the change. Also, all duty holders should be aware of the information they are responsible to pass on to other duty holders to ensure the correct specification procurement and installation of anchors. Focusing now on specification. Within section 5 of the standard, it gives you all the information that you need to ensure that you specify an anchor correctly. As you can see here, it even gives you a flowchart on how to follow the specification process. If we focus on the first section of that, which is the information required for the initial selection of an anchor, as you can see, it is an extensive list. Now, we don't always get that information, but the more the information that specifiers can have from this list, it will make the job easier and quicker. So to highlight the importance of having as much of this information as possible, we're going to look at a quick example. So here we've taken this example from a facade railing system. And for this particular system, the specifying engineer recommended the use of a 7.75 millimeter diameter screw anchor that was ETA approved and had a max permissible load of 3.8 kilonewtons. However, the bracket that the anchor was to be installed into had clearance holes of 11 millimeter diameter on the bracket. Now, this is a problem because if we look at the ETA approval, so that's the European Technical Assessment approval for the anchor, for the 7.75 version, you can see highlighted here that the maximum diameter of clearance hole is 9 millimeters. Now, this is to ensure that the load is transferred from the base plate to the anchor as expected under the Eurocode 2 Part 4 design methods. So unfortunately, for this particular example, the 11 millimeter clearance hole was too large, and this is an example of incorrect anchor selection. Once the specifier has selected an appropriate anchor for design, they then need to work out which design method they should utilize for the connection in question. The quickest way of doing that is consulting the ETA approval of the anchor and looking in the specification of intended use section, where it will always give what design method the anchor should be designed in accordance with. So here, we've got IFSA 2+, and it's intended for design with Eurocode 2 Part 4. And the easiest way to do that design is to utilize an anchor design software, such as Fischer's C-Fix Design Suite. Within it, you can design the anchor and then publish a design report, and this will be important for the Building Safety Act for that design work compliance, because within the report, it will state what ETA approval has been utilized for this anchor, so that's where the characters and data used for design has come from, as well as detailing which design method the anchor has been designed with for this particular design. Also within the report will be a full breakdown of the verification calculations for anchor failure. What shouldn't happen is the use of load tables. Now, we publish load tables to help with the selection of the anchor, but not for design. The intention of them is to give you an idea of the load capacity that could be possible with the anchor in question. What should never ever happen is that justification for an anchor connection design be made solely on the basis of the loads given within the load table. Again, we will revisit our facade example, again with our 7.75 millimeter diameter screw anchor. So as I mentioned before, the specifier stated that had a max permissible load of 3.8 kilonewtons, which they took from the load table for this specific anchor. And for the bracket that we're considering, there were 2 anchors were to be used for that particular bracket. The first issue here is that 3.8 kilonewton load that they have said is the max permissible load is only applicable in tension according to the load table and for non-cracked concrete only. But as we know, the assumption should be made that all concrete is cracked unless proven otherwise. So as we can see, the specifying engineer worked out what load would be applied to the bracket, but instead of carrying out correct anchor design, what they did instead was simply times that max permissible load by 2, the amount of anchors they had in the bracket, and decided that that would be the maximum load capacity of the particular bracket, which unfortunately is incorrect. Now, why is this incorrect? Because it doesn't take into consideration the fact that the anchors are closely placed to one another. So their zones of influence, so this is the area of the concrete where it gets its load bearing capacity, will overlap, which will decrease that max permissible load of the anchor. So unfortunately for the designer, as we can see again from the ETA, it is stating that its characteristic spacing, so this is the spacing that the anchors need to be considered as single anchors, is 3 times the embedment depth. In this instance, the embedment depth is 40 millimeters, so that means the characteristic spacing is 120 millimeters. And as we can see here, the actual spacing for the bracket is 100 millimeters. So this has to be considered as an anchor group. And as I say, as an anchor group, it means that there's zones of influence, as you can see in the figure here, overlap, and this is why we need to utilize correct design methodology to work out what the load bearing capacity of the anchors will actually be, rather than simply timesing the max permissible load by the amount of anchors in a bracket. So, unfortunately for this specifying engineer, this is an example of incorrect anchor design. Now, how does this tie into the Building Safety Act? Well, earlier we went through the principal designer's main requirements regarding their competency, and one of them was the management of design work compliance for all designers. So essentially, if the designer of that facade system had submitted that anchor design to the principal designer, it would have been rejected and they would have been asked to redo it utilizing the correct design method. So we'll have a look at what design methods should be used for both concrete and masonry, the two main substrate types for post-installed anchors. For concrete, this is managed by the European Commission, and as I mentioned before, the main design method is Eurocode 2 Part 4. Now, there are various design methods under it, and it also covers dynamic, seismic, and fire approvals. A sub-design method of it is CN Technical Report 17079, which looks at anchor redundancy for overhead systems. Finally, we have our own Fischer ENSO design methods, which is based upon FIB Bulletin 58. A limitation of Eurocode is it allows for only 9 set anchor layouts, and there will always be a requirement for custom anchor layouts, and that is managed by the Fischer ENSO design methods. Moving on to masonry, this is looked after by the European Organization for Technical Assessment, so the body that issues the ETA approvals, and the design of masonry is covered in Technical Report 54, which covers design for screw, chemical, and fire. Moving on to key duty holder responsibilities under procurement. So the contractor has got the main responsibility for procurement, as well as ensuring that the anchor is then installed correctly. This is achieved by following the specifier's specification and anchor connection design that's provided to them, and then ensuring that the installer has all the correct installation equipment, as well as having had sufficient training on the installation of the anchor. To aid the contractor with their procurement and installation, the specifier must provide them with the following information. Firstly, a fully detailed design and drawings of the anchor connection. Then a detailed specification of the anchor system, as well as the required installation accessories. And finally, they need to ensure that they've got installation instructions from the anchor manufacturer that they can use to train the installer. The best way for them to do this is to issue the contractor with a CFIX design report, as well as the ETA approval for a Fischer anchor. The reason being, within the CFIX design report, there's a breakdown of the anchor system and required installation accessories, including the article numbers if it's an item that Fischer supply. And there's also detailed installation instructions. So for this chemical anchor, we know how deep the installer needs to drill into the concrete, the exact cleaning procedure for this anchor, as well as the amount of scale units of chemical resin that needs to be injected into the drill hole. All key information the installer needs to know to ensure the anchor is installed correctly. Finally, within the ETA, you have the step-by-step instruction on how to install the anchor. Often during construction projects, there is a need to change product specification, and this is recognized within the British standards, and it gives a few examples, as you can see in the screen, for why you might need to change a construction product or post-installed anchor in this instance. But to give you an idea of what can go wrong with change of specification, here we've got a Juliet balcony installation in masonry. Now, the contractor opted to switch from the specified vinyl ester chemical anchor system to a polyester anchor system based on price. And they justified it by saying that both the vinyl ester and the polyester chemical systems had an ETA approval for use in masonry. Unfortunately, the anchors failed when a man came and leaned against the side of that Juliet balcony. The anchors failed, the balcony fell away, and he fell to the ground, breaking both of his legs. Now, what was the cause of this failure? It was the fact that the polyester resin, while it did have that approval for use in masonry, the approval was for internal use only. That was because the polyester resin in question was adversely affected by even the moisture in the atmosphere greatly reducing its bond strength capacity. So no change management procedure was followed, and that resulted in this man unfortunately breaking both of his legs. While the standard does state there is a need to change specification, those specifications should always be done either by the original specifying engineer or by another engineer who has access to the original design data so they can replicate the original design for the newly specified anchor. The quickest way to carry out a change management procedure, as I say, is to simply recreate the anchor connection design with our CFix design tool if you wish to use a Fischer anchor. If anyone other than the original specifying engineer or a newly appointed responsible engineer makes the decision to change the specification of an anchor, then they will be taking on engineering responsibility. So for the example we just looked at, the contractor would have overall responsibility for that anchor connection and therefore the failure of that anchor. Now, how does this tie back into the Building Safety Act? Well, as we spoke about before, there is a requirement for any changes made to specification following Gateway 2 to be captured within the golden thread via change control process log. As a recap, the client will be required to submit a detailed design at Gateway 2 to the Building Safety Regulator for approval. So this will effectively be the document that will state this is how we are going to build this particular building. So this involves a detailed review of the construction plans, materials, and safety measures. The BSR will then have to give their approval, and only after that approval can construction begin. Following the start of the project and progression through Gateway 2, any changes to the design or product specification will need to be captured within the golden thread via the change control process log we mentioned before. At Gateway 3, the client will then need to submit an as-built document to the Building Safety Regulator, and the regulator will compare that against the document submitted at Gateway 2 and then refer to the change control process log within the golden thread to ensure that if there have been any changes to any design or specification, they followed the correct procedure. And that procedure for post-installed anchors is the one we looked at from British Standard 8539. Now, the reason for all of these requirements around change management procedure, control process logs, regarding product specification is a direct result of Grenfell. I think most people are aware that one of the major reasons for the Grenfell disaster was the change of the specification of the facade paneling to one that was not suitable for the fire requirements of the building. Following the Grenfell disaster, the Construction Product Association and NBS carried out a survey on product specification, and what they found is that from their respondents, only a third of them said that whenever they carried out a change of product specification, they always got approval for that change. Now focusing on the control process under the Building Safety Act in a bit more detail. So within the Building Safety Act, it makes clear that any change to a specification needs to be detailed as either being a major, notifiable, or recordable change. A major change requires approval from the Building Safety Regulator and can take up to 4 to 6 weeks. Notifiable changes also require approval from the BSR and should take less than 2 weeks. Recordable doesn't require any involvement of the regulator. However, both the principal designer and contractor have to approve of the change. And all of these changes have to be captured within the control process log for review at Gateway 3. For construction products, Regulation 26.2 states the following. When an agreed document specifies use of a construction product or building element falling within a specified class, the change to another product or element falling within the same design specification is a recordable change. So in short, all changes of construction products after Gateway 2 are a recordable change. So any change to a product specification has to be approved by the principal designer and the principal contractor. As mentioned, for post-installed anchors, following BS 8539's change management procedure will ensure that you adhere to the new requirements set in place by the Building Safety Act regarding product specification change. So now focusing on installation of post-installed anchors. As we looked at before, the contractor does have overall responsibility for installation as well as the overseeing the installer's practice. In order to achieve that, they need to ensure that the installers are fully trained in how to install the anchor and have all the correct installation accessories available to them. So, as we say, it is imperative to ensure that the installer has had necessary training via an anchor toolbox talk from the manufacturer. Now, this can be done online or in person. If the installer does not install the anchors as per the manufacturer's guidance and to the specified design, then the installer themselves will be taking on responsibility for that anchor connection, and by default, the contractor, because as we say, the contractor does have overall responsibility for the installer. To help support contractors and installers, Fischer always make available as many of the installation accessories required for installation, as well as the provision of toolbox talks either on site or via our online platform. We can also provide training for supervisors to oversee the installation of anchors. And this all ties back into the Building Safety Act, as if you remember, the principal contractor has a responsibility to ensure the management of the competencies of installers of safety critical applications. So what this means is the contractors will need some form of record to ensure that the installer of post-installed anchors has had the necessary training to ensure they will install that anchor correctly. To help contractors adhere to the new competency requirements regarding installation, as mentioned, Fischer can come to site to provide toolbox talk training. We also make information required for correct installation available from our CFIX design report and ETA approvals. Within the CFIX design report, there is a breakdown of all components of the anchor installation system and required installation accessories, as well as detailed information on how to carry out the installation. Within the ETA, you then have the step-by-step guide on how to correctly install the anchor in question. We also can make available dedicated method statements for particular installations for contractors. And we have our online training portal where we have an array of online toolbox talks, and we can also set up contractor-specific online portals so we can generate databases of installers who have undertaken the training to make that available to contractors. So to highlight the importance of anchor installation, we're going to look at a few bad practice examples. So there will always be instances on projects where the conditions on site don't match up to what's within the design. For example, concrete upstand being out of tolerance. So in these instances, the communication between the duty holders to ensure the anchors can be installed correctly becomes absolutely paramount. For a first example, we have this collapsed air conditioning unit. Now, while there wasn't any issues with the concrete it's been installed into, as you can see here, no amount of PPE was going to save any workman stood underneath that unit when it came down. Luckily, it came down overnight when nobody was on site. Now, the anchor that is highlighted here is what we call a hammer set drop-in anchor. Now, these anchors need to be set with the appropriate setting tool to ensure that the expansion element of the anchor fully expands into the drill hole. Unfortunately, on this project, you can see that this anchor has barely expanded, and that's because they were using a bit of threaded bar to set the anchor. So this highlights the importance of ensuring that the installers have the correct installation accessories on a project. Next, we've got a steel beam support utilizing a resin solution. And as we can see here, we have one that is sticking out by a considerable amount compared to the others. Now, the reason for this is because they've hit rebar. So there's shallow rebar in this concrete slab, which wasn't considered during the design of the anchor. And unfortunately, when the installers hit the rebar, they have a tendency to install the anchors at that depth. Now, the problem here is you're reducing the load bearing capacity of the anchor, and you're also changing the installation from what has been specified in the design. So as I said before, this will mean that the installer will be taking on responsibility for that connection design, because effectively they have changed it and not had it approved by the designer. Now we're going to look at a quick case study of a facade anchor point. So for this particular project, our involvement began when the supervisor on site called us up to say that our anchors were failing during installation. Now they sent through this photo of our anchor, and you can see here it is snapped at the location where the expansion clip is. Now, the reason for this is because they were over torquing the anchors. They were utilizing impact drivers rather than calibrated torque wrenches, because all torque controlled expansion anchors require a set installation torque, which cannot be achieved with impact drivers. However, I did go to site to investigate further, and there were other issues that I discovered. So here is one of the connection points for the facade frame, and unfortunately, it transpired that they were utilizing casting channels with post-installed anchors. Now, unfortunately, while the Eurocode 2 Part 4 does cover the use of post-installed anchors and casting channels, it doesn't allow for design of both for a single application. So to clarify, for an application, you must use either a post-installed anchor solution or a casting channel solution. The reason we have both here was the intention for the post-installed anchors was that they were to be used as a backup if the casting channel had been installed in the wrong location. An additional issue with utilizing post-installed anchors and casting channels in this particular scenario was the fact the post-installed anchors were located far too close to the casting channel. So when the anchors were then over-torqued by the impact drivers, it was causing the concrete between the casting channel and the post-installed anchor to begin to crack. Now, unfortunately, what this means for the connections affected is that essentially this connection point was unsafe and needed to be replaced. There were additional issues with the connection points that I reviewed. So as we can see here, you've had the addition of shims that were not included in the original design. If shims are ever to be used with an anchor connection point, then they need to be included in the design of it. Reason for this, it will affect some of the failure mode verification calculations. So this is why it has to be detailed. Also, as we can see here, there's an anchor missing from the installation. And this was due to the fact that, again, they were hitting rebar at a shallow depth. And in this instance, they did flag it to the supervisor. And this was something that we discussed on site along with the other issues highlighted. Under the British standard, anchor manufacturers are also classed as a key duty holder. This is because we have all of the information required by the other duty holders to ensure they fulfill their responsibilities as advised by the British standards. End of the day, Fischer are an expert in post-installed anchor connections, anchor design theory, as well as the British Standard 8539. This means that we are the best resource for information regarding post-installed anchors and the other technical construction products that we offer. We can also assume the role of anchor tester under the British Standards, as we do offer a range of anchor testing services. For specifiers and contractors, there are two types of anchor testing that they need to keep in mind. For specifier, you have suitability testing. So this is when you may be dealing with a substrate that you don't have all the information about, but you need to assess whether or not the anchors will be suitable for use in that substrate. For contractors, as they have responsibility for overseeing the installation, they will need to utilize from time to time what we call proof testing. So this is simply anchor testing to check whether or not the anchor has been installed correctly. All anchor testers have a responsibility for performing anchor testing in accordance with the guidance set out in British Standards, Section 9 and Appendix B. The exchange of information between duty holders is key to successful implementation of the British Standard 8539. Essentially, the standard will help create a thread through all the required actions to specify, procure and install ETA-approved anchors. Those adhering to the British standard will be achieving a gold standard of best practice and ensuring compliance with the new requirements set out under the Building Safety Act. Hopefully, this video has been informative and helps you understand the new requirements for all parties regarding the Building Safety Act and how best to achieve those requirements utilizing the guidance given in British Standard 8539. If you would like further information or the full version of this seminar, please contact our Fischer Technical Helpline using the contact information below. Thank you for watching.